Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures as usual. So the lesson objective for today's lecture is all about metallic bonding. So candidates should be able to define metallic bonding as the electrostatic force of attraction between positively charged metallic ions and sea of delocalized electrons. So we'll be considering metallic bond for today's lecture. So please, I want us to pay attention and get the best out of today's lecture. So we are looking at metallic bonding, which is the type of bonding that is found in metals. This type of bonding always occurs in metals only, and it varies from one metal to another metal. That's why some metals are stronger than others. So when we talk about a metallic bond, it is the electrostatic force of attraction between the delocalized electrons and positively charged metallic ions, which are the cation ions. Sea of delocalized electrons. When we talk about delocalized electrons, we're talking about free mobile electrons. You know, metal ionizes by losing electrons, and when they lose electrons, they become positively charged. So what happens is that in a metal, the atoms lose several of their outer electrons, which drift around between the metal ions as free electrons, as delocalized electrons. So if you look at the structure here, we'll have the positively charged ions. If you look at the structure, we'll have the positively charged ions surrounded by what? Sea of delocalized electrons. These are the free mobile electrons. You can see the positively charged ions and the sea of delocalized electrons. The electrons are spread around the nucleus. So that electrostatic force of attraction, you know, positive, negative attracts. So that force of attraction between the positively charged nuclei and the sea of delocalized electrons is what we call what? Metallic bond. And it varies from metal to metal. So when we talk about metallic bonding, we talk about the electrostatic force of attraction between the positively charged metallic ion and the sea of delocalized electron, or the positively charged nuclei and the sea of free mobile electrons or delocalized electrons. So we're looking at metallic bonding, which is the electrostatic force of attraction between the sea of delocalized electrons and the positive nuclei or the positive metallic ion. Now the strength of the metallic bond varies from metal to metal. So we're considering the factors that affect the strength of the metallic bond. So metallic bond strength depends on two major factors. One is the number of electrons donated or the ionic charge. The number of the electrons donated or the ionic charge. Then the next is the size of the metal atom or ion, or we call it ionic size or ionic radius. Now we're looking at the number of electrons donated or the ionic charge. Aluminium, for example, ionizes by losing 3 electrons, so the ionic charge is plus 3. Sodium ionizes by losing 1 electron, the ionic charge is plus 1. So here the ionic charge is plus 3 and the ionic charge here is plus 1. So 3 electrons are donated for aluminium, 1 electron is donated for sodium. So the strength of the metallic bond in aluminium is stronger than the strength of the metallic bond in sodium. Sodium is soft, so it can be cut with a knife. So the fewer the number of electrons donated, the weaker the strength of the metallic bond. The fewer the number of electrons donated, or the smaller the ionic charge. So the higher the ionic charge or number of electrons donated, the stronger the strength of the metallic bond. Or the smaller the ionic charge or number of electrons donated, the weaker the strength of the metallic bond. That is why aluminium is stronger than what? Sodium. Aluminium as a metal is stronger than sodium as a metal. Sodium can be cut with a knife. So these are the factors that affect the strength of the metallic bond. Then the other factor is the size of the atom or ion, which talk about the ionic size or ionic radius. Now, the smaller the ionic radius or ionic size, the stronger the strength of the metallic bond, and vice versa. You know, the smaller the ionic size or ionic radius, the higher the charge density, so the stronger the strength of the metallic bond. Let's say sodium ion and potassium ion, both of them have a charge of +1. But sodium have a smaller ionic radius, smaller ionic size compared to what? Potassium. So the strength of the metallic bond in sodium is stronger than the strength of the metallic bond in potassium. So the ionic size or the ionic radius affects what? The metallic bond strength. The smaller the ionic radius or the smaller the ionic size, the stronger the strength of the metallic bond. The larger the ionic radius or ionic size, the weaker what the strength of the metallic bond. So these are the two major factors that affect the strength of the metallic bond. So having considered factors that affect the strength of the metallic bond, now I want to look at properties of metals. What are the properties of metals? What are the characteristics of metals? The first one we'll be considering is high melting point and high boiling point. Yes, metals have high melting point and high boiling point, which is as a result of the strong electric force of attraction between the positive nuclei and the sea of delocalized electron. So the metallic bonds between positive metal ions and the delocalized electrons are strong. So high temperature needed to break the metallic bonds. So the melting point and the boiling point is a measure of the attractive forces within the metal. So we'll talk about the boiling point and the melting point. We use it to measure what? The attractive forces within metals. If you look at what we have here, if you look at from sodium to magnesium to aluminum, we are going across the period. So the ionic charge increases, the number of electrons donated increases, the number of electrons the atom shares increases. So since the number of electrons decreases, what happens is that what the strength of the metallic bond will increase. So the boiling point will increase as you go across the period, which is as a result of what increase what in the number of electrons donated or increase in ionic charge. Then if you look at the group, as you go down the group, what happens is that what the size of the ion or the ionic radius or the ionic size will increases. So since the size of the ions or the ionic radius increases, what happens is that what the strength of the metallic bond will decrease. So the melting point decreases as you go down the group. So this one major properties of what metals, which is high boiling point and what high melting point. So the next one is metals are good conductors of electricity. Yeah, good electrical conductors, and the reason is because metals have free mobile electrons, delocalized electrons. So the delocalized electrons can move freely anywhere within the metallic lattice, allowing them to conduct electricity. So they conduct electricity as a result of what free mobile electrons, the free delocalized electrons. So that is one major properties of metals, that they can conduct electricity, and it's as a result of the free delocalized electrons. The electrons are free to move so that they can conduct electricity. So the next is malleability. Yes, malleable. Metals are malleable. They can be beaten or hammered to any desired shape. So the word malleable means that the metal can be hammered and beaten to any desired shape. The metals are able to roll over each other into a new position without breaking the metallic bond. So they are malleable. They can be beaten to any desired shape. So the reason is because the metallic lattice consists of the positive nuclei and the sea of delocalized electrons. So since the electrons are constantly moving, the electrons they move freely. So once beaten to any desired shape, it will form a new metallic bond, making it malleable and not breakable. So metals are malleable. So the next is ductility. Yes, metals are ductile. Ductile means they can be drawn out into a wire. So this is also due to the ability of the atoms to roll over each other. Yes, metals are ductile. They can be stretched into a wire. You can see there's copper wire. Copper metal can be stretched into a wire. Iron metal can be stretched into a wire. Aluminum metal can be stretched into a wire. So they are ductile, which means they can be drawn out into a wire. So it's as a result of due to the ability of the atoms to roll over each other, so they can be drawn into the wire. So this is a typical examination question. You are asked, copper is used in electrical equipment. It has a melting point of 1085 degrees Celsius. You are asked to identify the lattice structure of copper. Copper is a metal, so when we talk about lattice, it has to do with the arrangement of atoms, molecules, and ions in a regular repeating pattern. So the lattice structure of copper, which is a metal, is the arrangement of positively charged copper ion surrounded by a sea of delocalized electrons in a regular repeating pattern. So the lattice structure of copper is giant metallic lattice. Metallic lattice. Then the next one is draw a Lambda diagram to show the bonding present in copper. Copper is a metal, so it has to do with positively charged ion, positively charged ion, positively charged ion, positively charged ion, surrounded by sea of delocalized electrons, positively charged ion, positively charged ions, surrounded by sea of delocalized electrons, surrounded by sea of delocalized electrons. So this is a typical metallic lattice which consists of positively charged ions surrounded by sea of delocalized electrons. So this is a typical what? Metallic lattice structure of copper. So you can solve as many questions as what possible. So it's as simple as A, B, C. So before us is a typical examination questions for us to attempt. You know, this multiple choice, and we've discussed metallic bond, we've discussed properties of metals. So the question is, copper has a high melting point. What is the reason for the high melting point of copper? You know, copper is a metal. So let's look at the options. We are going to analyze the options. The first one is a strong attractive forces between copper atoms only. No. B is strong attractive forces between copper ions and delocalized electrons. Correct. B should be the answer. C is wrong because it says strong attractive force between copper ions only. Wrong. D is strong attractive force between copper atoms and delocalized electrons. Wrong. So the correct answer is B, which is strong attractive forces between copper ions and delocalized electrons. Strong attractive forces between copper ions, positively charged copper ions, and delocalized electrons. So the correct answer is B, because metallic bond is the strong electrostatic force of attraction between the metallic ion, which is the positively charged ion, and the sea of delocalized electron. So it's as simple as A, B, C. Please attempt as many questions as possible based on this topic, and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. So attempt as many questions as possible. I'm Mr. Joseph, your chemistry teacher. Please don't forget to subscribe to my YouTube channel, share, like, comment, and feel free to reach out to me for any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Please subscribe to my YouTube channel. Mr. Joe, your chemistry teacher. Thank you for listening.